All right. Question type number 3. It says find the launch speed and angle from the impact data, specifically if it's on level ground. Now that's important to know because it tells us a lot. We'll see that when we draw the picture. A rock is thrown from flat ground and lands 28 meters away after 2.2 seconds of flight, returning to the same height. So sketch the picture. Whee. That flat ground tells me that it starts and it ends at the same height. So dy, if I'm thinking about the total trip, equals 0. It ends at the same height that it starts at. Now they tell us it lands 28 meters away. What they're telling us is that the dx is 28 meters. And that it took 2.2 seconds, time equals 2.2 seconds to do the whole trip. It says, what is the rock's initial horizontal velocity? Well, the only equation that ever ends up working in the x direction for these projectile motion is dx equals v initial x times t plus 1/2 axt squared, and every single time that ax goes away, so I'm left with dx equals v initial x times t. In order to be able to solve for v initial x, I would need to know dx, which I do, and I would need to know time, which I do. Plug and play, 28 meters equals v initial x times 2.2. V initial x equals 28. Sweet. Finished with A. What is the rock's initial vertical velocity? It's going to take me a second to think about. Let's see. I could use this d total trip. I could use dy equals v initial y times t plus 1/2 ayt squared, and I could say 0 equals VIY is what I'll solve for. Time is 2.2. 1/2 negative 9.8. 2.2 squared. Alright, so I'm going to calculate that real quick. Negative 2.2 v initial y equals 0. All right. So that one ended up working. My initial instinct was to actually just cut the whole problem in half and say that this took 1.1 seconds, and then I would have used v final y equals 0. So if I had done that alternate method, I would have done VF equals VI plus AT, 0 equals Y. I'm going to T. I was wondering what I knew. But this time the T would be 1.1 because I would only do the time it takes to get to the top. So let's see, 9.8 times 1.1. Gives me VIY as 10.78. So I get the same answer both ways. You didn't necessarily need to see, the two different ways, but I got excited. So, okay, part C, what is the rock's initial speed and launch angle? Now, when it's talking about initial speed, but it doesn't specify vertical or horizontal, what it's really asking about is the hypotenuse. So, at that initial moment, it's got some amount of horizontal velocity, 12.73. It's got some amount of vertical velocity, 10.78. We just need to find that hypotenuse. So, a squared plus b squared equals c squared. .92 meters per second as my overall speed, and then the angle right here, theta, tangent of theta is equal to my opposite of 10.78 divided by my adjacent of 12.73. So theta is the inverse tangent, 10.78 all over 12.73. Hmm, 2.6. Sure, why not? That is the end of question type number 3.